Welcome to our pre-video notes video. Ladies and gentlemen, we are going to understand the conceptual ideas behind solving equations. So we're going to talk about some very important things here. Mr. Ross is going to show you a model, and then hopefully when you get to having to write all this stuff down, it will make sense to you. So in solving equations, ladies and gentlemen, there are two extremely important goals to solve these equations. And these goals are important because they will work in every single equation that you have to solve. I don't care how complex, I don't care how challenging, you can use these to solve that equation. So the first goal we're going to talk about is isolating the variable. That's the unknown quantity, the unknown value. And we have to get that variable all by itself on one side of the equal sign. Hello, that means we're going to isolate it on one side of the equal sign. And then we're going to keep that equation balanced. In other words, we're going to keep the equation equal because there's an equal sign between the two sides of the equation, meaning that they are the same. No matter what they are, they're the same. All right. And how do we keep the equation, or what does it mean to keep the equation balanced? It means whatever you do to one side, you do to the other. All right? So isolating the variable, how do we do that? Our first goal, isolating the variable, getting it all by itself on one side. There is a mathematical procedure. It's called using the inverse operations, the opposite operations to isolate that variable. Addition and subtraction are opposite operations. They undo each other. They make zero when we talked about that. We have multiplication and division are inverse operations. They undo each other. They make zero. So what you see me do in my one model here will also work if we're doing multiplication and division equations. Doesn't matter what it is, we're going to use opposite or inverse operations. And whatever you're doing to one side when you do to the other, that's called using properties of equality. It keeps the equation true. It keeps it equal. And that's what we want to do. So here we have this model, the scale right here. The scale, the reason I use a scale is because the scale right now with nothing on it, it is balanced. That means nothing on one side is equal to nothing on the other. So let's put something on one side. Here we have this box, this blue box, plus we have these 4 red stars. And we're saying that it is balanced with this other side that has these 13 red stars. So we can now use what we see to write an equation. And I can say that this box is represented by x. It's my variable. It's my unknown quantity. Plus the 4 stars has to be equal to the 13 stars we see on the other side. So we have an equation that is modeled. X plus 4 is equal to 13. Equal because they are balanced. Everything on one side is balanced with everything on the other side. So it's got to be equal. So we have x plus 4 equals 13. And we talked about isolating the variable first. So we look at our variable, our blue box. It's our unknown value. We got to do the inverse or opposite operation. Right now it says we're adding 4. We're adding those 4 red stars. So we're going to do the opposite of that. We're going to subtract 4 stars. And we're just going to take them right away. Boom, 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 and boom. Now you know if we only took 4 off of the one side, what would now happen to the scale? That's right. The scale would not be balanced anymore because -4 and a +4 make 0. So now you have x plus 0. Well, really, you only have x because x plus 0 is equal to x. That is the identity property of addition. So now we have x. But still, it's not balanced. These 13, we took 4 away from one side. This scale would not be balanced anymore. So we have to do our second goal, which is balance the equation. What did we talk about? We said whatever you do to one side, you do to the other. So since we subtracted 4 stars from the one side, we're going to now subtract 4 stars from this side. And that means we don't have 13 anymore. We now have 9. And so x is equal to 9. We have a balanced scale. We did the same thing to both sides. We isolated the variable. Now we have our solution. That means there's 9 stars in that box. Now I know you could probably have done that mentally because you're that sharp. that makes no difference. Right now we are learning the process because they are going to become more complicated, and you're going to need to be able to follow some sort of logical reasoning to come up with an answer. What is that logical reasoning? Well, let's isolate that variable and keep the equation balanced using inverse operations and properties of equality. Ladies and gentlemen, thank you very much. Let's go take our video notes.